All right, in our day 10, cut. All right, in our day 7 notes, we're going to talk about solving equations, specifically linear, quadratic, and rational. So for a linear equation, I think we're all okay with that. We just have to get x by itself by doing the opposite of the order of operations. No big deal. Quadratic, when we're solving quadratics, right now we're only going to find real solutions, so we're not going to worry about the imaginary number I. So we have three methods. First one is the factoring one. Remember, when you're factoring, you must set the equation equal to 0 and then factor it and solve it. That way, set each factor equal to 0. I don't think we'll have any issues with that because we just got done factoring. Undoing or extracting the square root is kind of like the linear functions, but we have to square root at some point. Whenever we get x by itself, we have to square root. So for example, 1, if we divide both sides by 3, we get x squared equals 20. But x is not by itself, so we have to square root both sides. Now, when you take the square root to solve, whenever you're asked to solve and you end up taking the square root, you must have plus or minus. You also have to keep in mind to simplify the radical. 20 can be broken up into 4 times 5. Well, the square root of 4 is 2, so we have x equals plus or minus 2 root 5. Those are our two solutions. Now, this one, our x is stuck in a parenthesis with that minus 4. So we have to isolate that first, the parenthesis, and then we can square root this. Okay, square root both sides. At this point, it becomes x minus 4 equals plus or minus the square root of 5. Well, x is not by itself yet, so we'll add 4 to both sides. So then our final solution would be x equals 4 plus or minus the square root of 5. That's our exact answer. We don't need to type it into the calculator because we're not asked to give a decimal approximation. So undoing the square root isn't too bad. Quadratic formula, well, you have to make sure this is set equal to 0. And then you have to use the quadratic formula, which I'll write down in a minute. Okay. So whenever it equals 0, you should check to see if you can factor. We can't factor this, so we have to use a quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so then let's substitute in our values. We have x equals negative 9 plus or minus the square root of b squared. So b is negative 9 again, minus 4 times a is an invisible 1, times c all over 2 times 1. Now we get x equals positive 9 plus or minus. That in your calculator is 109. This the discriminant right here over 2. Now we can't simplify the square root of 109, so that stays the way it is. We can't reduce the fraction 9 over 2, so that stays the way it is, making this our final answer. You also had learned how to complete the square. What completing the square does is it takes a quadratic that is in standard form that you can't factor, and instead of using the quadratic formula, you turn it into something that you can use the square root property to solve. So in order to do completing the square, you have to make sure your a value is 1 and that your c value is on the other side of the equation. So we're going to subtract 5 from both sides. X squared minus 8x equals negative 5. Now to complete the square, what we do is we take our b value, divide it by 2, and then square it. So b value is -8 divided by 2 and square that. That equals -4 squared. Oops, I'm going to write that a little bit lower. So that would equal -4 squared, which is 16. So we're going to add 16 to both sides of the equation. So x squared minus 8x plus 16 equals -5 plus 16. Now you're going to be able to factor this into a perfect square trinomial. And the reason why I wrote out this step over here is that when you factor this, it's always going to use this number squared. I mean, yes, you can still factor what I highlighted in blue, but you can, again, just look at what we have over there. We did -8 over 2, which gave us -4. So it's going to be x minus 4 quantity squared equals 11. Now we can square root both sides, and we get x minus 4 equals plus or minus the square root of 11. And then when we add 4 to both sides, we get x equals +4 plus or minus the square root of 11. And we can leave it like that, like we did above. We don't need to write two separate solutions. Now we look at this one, you might notice, well, our a value is not 1, so what do we do? So we still make it equal to their c value. And then you can do a couple things. You can factor out a 4, but then you'd have to multiply by 4 once you do the complete the square part, and it would be a little bit more work at the end. Instead of that, we can divide everything by 4. So then we get x squared plus 2x equals -1/4. So now that we have our a value equal to 1, we can complete the square. Our b value is 2, so 2 over 2 squared, so 1 squared, which is 1. So we're going to add 1 to both sides. -1/4 plus 1, which 1 is the same thing as 4 over 4. We need common denominators in order to solve or to simplify. So the left side is going to factor to x plus 1 squared equals 3 over 4. So then we will square root both sides. And when we square root the left side, we get x plus 1 equals the square root of 3 over the square root of 4, which is 2. We have to make sure we do plus or minus. And then finally, we're going to subtract 1 from both sides, so x equals -1 plus or minus the square root of 3 over 2. And we're going to leave our answer just like that. So you can see completing the square isn't always the easiest or the most straightforward method. For this one, it wasn't too bad at all just to do completing the square to get our answer. This one, we had to do a little bit of work and had to work with some fractions. So you might have said, let's use the quadratic formula instead. And you would have had to reduce some fractions at the end if you would have done that. So just keep that in mind as well. Some of these problems are just more difficult or time-consuming to solve. There's really no shortcut. You just have to, chug through it. All right. So with rational equations down here, if you ever have just a fraction equals a fraction, you can cross multiply. This one, we don't have a fraction equals a fraction, so we can't cross multiply. What we would want to do instead is multiply both sides by a value that gets rid of all of our fractions. So if we multiply everything by 10, and the reason I'm using 10 is because 10 divided by 5 gives us a whole number, 10 divided by 2 gives us a whole number. So what that will do is give us 10x over 5 minus 10x over 2 equals 30. Right, then we can simplify 10 over 5 is 2, so we have 2x minus 5x equals 30. All right, now this is just a normal linear equation that we can solve. 3x, negative 3x equals 30. Divide by negative 3, x equals negative 10. So we were able to get rid of all the fractions by multiplying everything by the least common denominator. Now, letter B, we do have a fraction equal to a fraction, so we could cross multiply. The problem with cross multiplying this one is that we have n times n plus 2 in the denominator, which will give us n squared. And if we do that, we could have two potential solutions, and we'd have to check for extraneous ones. Instead, what we'll do is we'll multiply by the least common denominator, which in this case is going to be n times n plus 2. And what that will do is for each of these, it will eliminate the denominator. And I'm going to write it out for this one just so again that you can see. So we have 3 times n plus 2 over n plus 2 equals 12 times n plus 2 over n times n plus 2. So we cancel these off. We get 3n. Cancel this stuff off, equals 12. So you will be able to skip that red step eventually and just look in the first one and say, okay, I know that the n plus 2 here is going to cancel with the n plus 2 there to give me 3n. And I know for the second one that everything will cancel and I'll be left with just 12. So we'll divide both sides by 3 and n is equal to 4. So I think that was much easier than cross multiplying. All right, letter C, we have 3 fractions. We want to factor the factor the denominator of the right side. So this is going to give us 1 over x minus 2 plus 3 over x plus 3 equals 4 over, and this factors to x plus 3 times x minus 2. So that's convenient because the least common denominator between all 3 of these is the quantity x plus 3 times the quantity x minus 2. So if we multiply everything by that, x plus 3 times x minus 2, what that's going to do for us is in that first fraction, the x minus 2 and the x minus 2 will cancel, and we're left with 1 times x plus 3, so that's just x plus 3. In the second fraction, the x plus 3 is going to cancel with the x plus 3, and we're going to be left with 3 times x, 3 times x minus 2. And then the last one, everything's going to cancel, and we're left with just the 4 in the numerator. Okay, so then this is just a nice linear equation to solve. So we have x plus 3 equals 3x minus 6 equals 4. Oops, sorry, this should be plus. Combine like terms. We get 4x minus 3 equals 4. Add 3 to both sides, that gives us 4x equals 7. And then we divide by 4, x equals 7 over 4. So again, finding that least common denominator for all your fractions will eliminate the denominators and make life a heck of a lot easier. All right, the last one. We don't have to factor the denominator here, so we're going to multiply everything by x times x plus 1. So in the first fraction, everything's going to cancel out, and we're going to be left with 3. I probably should have said this when we were doing this in the letter A, but notice how I'm only multiplying the numerators because this is like multiplying by something over 1. It's different than when we were doing compound fractions or adding fractions when we multiply the numerator and denominator by a value. Here, I'm only multiplying the numerator by x times x plus 1. And that visible over 1 isn't needed. And I can do this because there's an equal sign. I'm doing the same thing on the left and right side of the equal sign, so it's allowed. As opposed to adding or subtracting rationals, if there's no equal sign, there's nothing to do to both sides because there are no two sides. So then the second fraction, the x plus 1s are going to cancel, so I'm left with 7x. And then the last one equals just 3 times x plus 1. So we get 3 plus 7x equals 3x plus 3. Minus 3 from both sides, we get 7x equals 3x. Well, then we subtract 3x from both sides, we get 4x equals 0. Well, that means x has to equal 0. But wait a minute, we have right here just x in the denominator. Well, if x is equal to 0, that gives us an undefined fraction. So this means there's no solution. So just get in the mindset of just double checking that your value for x does not give you a 0 in the denominator. So again, you did do this last year. Hopefully this kind of refreshes that. So thanks for watching the video. Make sure to smash that like button and subscribe.